Our next speaker is Mr. Praharaju Laxminarayana. He is the Managing Director of Bio Systems Pvt. Limited. He specializes in integrated pest management, promotion and marketing. He has developed an application of herbicide for weed control. The purpose of his presentation, as he states, is to focus on the importance of biopesticides and integrated weed management for sustainable agriculture. Ladies and gentlemen, my personal favorite, the only person I know who has done something as good as bioherbicides, Laxminarayana.
Good evening, ladies and gentlemen. After a hectic, sumptuous lunch we had, maybe we are all tired a little bit, but maybe I'll try my best to wake you up with my presentation. So, we are from a company called Bio Systems. We are going to talk about our we are basically into insect pheromones as well as bioherbicides and the biologicals, microbials especially, into insect pest, disease and weed control. We are based out of Hyderabad. So we are a 26-year-old company. We are established in 97. We are DSR recognized, ISO certified, GMP facility for manufacture. We are in pheromones, microbials for insect pest, disease and weed control. So today my talk will also mix, other than the agriculture part, maybe we will also look at some of the invasives, what we are facing trouble with. So invasives, they don't belong here. They are introduced in natural invasion, through natural invasion, or thrive in the local environment, competing with the native flora and fauna. Just to cite some examples, in pests, there is locust, tuta, fall armyworm. Diseases like alternaria, sclerotium and puccinia. Weeds like eichhornia, parthenium and lantana. So invasive alien species, or IAS, what they are called, over 300 are reported to be invasive. Exchange damages due to IAS in agriculture, forestry in India is to the tune of about 91 million. It is recorded way back in 2002. Maybe latest figures are not available in India. But if you see the cost in IAS in Australia is about 13.6 billion. And 2011, during 2011 is the estimate what has been made. And world figures stand at more than 1.4 trillion. So, if you see the pest as an invasive, they may come and they may migrate again. If you see as a disease, maybe it is controllable, it is specific to certain kind of a crop. But when it comes as a weed, it stays there. And invasive has the ability to amend itself, to grow in there. So today whatever I am presenting is on an alien invasive weed called water hyacinth, parthenium and lantana. So what are the damages they are doing to environment for this kind of impactation? So aquatic, it is depletion of water, eutrophication of ponds, depletion of dissolved oxygen, increased turbidity and fouling. In terrestrial and in forest, we have depletion of the nutrient, competing with native vegetation, loss of medicinal plants, reduced pastures and grazing lands. These are all affecting our food security also. This is again a very characterization of invasiveness of parthenium, lantana and water hyacinth. If you see, velocity of dispersal is highly dispersive, tendency of prevalence is dominant, level of threat to biodiversity is highly competitive, regional distribution is widely distributed. So these are the major points in these three weeds. So cost of environmental impact in lantana alone, if you see, in US is about 58 billion, and in India is about 25 billion, and Australia it's about 6.8 billion. If you compare with about 65 billion market of agrochemicals worldwide, this is overtaking that. This is the importance of the invasives what we are talking about. Now and again, water hyacinth, in USA it is about 35 billion, and Malaysia it's about $10 million, which is affecting. So with that background, we have developed 3 bioherbicides, basically mycoherbicides for water hyacinth, parthenium and lantana. They are distributing from Central America and South America to the rest of the world. See, on the left corner, what you see is water hyacinth, in the center is parthenium, and on the right side is lantana camera. They all invaded into more than 50-60 countries already and doing a lot of damage to the environment. Why bioherbicides? Basically, what do you have for organic farming? Do you have some weedicide? Except for flame throwing or manually removing, there's absolutely nothing. In a smaller areas, yes, it is possible, but in a large acre of agriculture and row crops and other things, it will be difficult in future. Aquatic weed control and environmentally sensitive areas, they don't prefer any chemical weediciding. This is again a very, very important area where we can look for alternative methods for the weed control. Now, weed resistance management, already we have so many weedicides, but we also have the problem of weed resistance management issues are coming up. So this is also one area where the bioherbicides can be mitigating the resistance factor. The prevalence of non-target area contamination. Non-target area contamination is very high. Right from our childhood, what we are taught for application of weedicide, flood nozzle, you have more water so that it will not have a drifting. To avoid drifting, flood nozzle was used. So what was retained on the target leaf of the weed is only 1%, and 99% were falling back onto the non-target area and contaminating in the soil and further to the water sources, groundwater and other things. And again, it is coming back into the food chain. So this is one of the major area for residue, chemical residues issues also. So this is where if we can have an alternative, we can do it better. Very few people are operating into this field, so that it is a niche area, and bioherbicides, maybe this is one of the reasons why we went in. In biopesticides, everybody talks about more of the pest control or insect control, then maybe some disease control, and literally we find very, very few people into herbicide area. Again, herbicide area is more than 35% globally if you see. So we also have a chemicals are restricted into sensitive areas and water bodies especially, because they are toxic to the environment as well as the fish. So what we started looking is, we are looking at things beyond microbes. So my earlier speakers have also touched upon some of the things why don't we work with metabolites, or why don't you work with the elutes of the microbes so that they will be more stable. Now, whether we like it or not, down the line, most of the countries have signed various agreements, international agreements for controlling global gases, release of CO2 and other things. So we have to fall in line for global warming. We have to do some kind of a restrictions will definitely come on the chemical inputs into the agriculture part. Now, when it comes, people are looking at what are the biologicals which will probably replace or fill in the gap. They have to be overcoming the kind of a problems what we are facing today is many challenges in live microbes to use. When you give a live microbe, first thing is shelf life issues. Second thing is the microbe has to settle into a new environment. If it is into the soil, the settling in process is much better and faster. Whereas if it is a foliar application, it becomes little difficult. Now, what we need to do to overcome this kind of a situation is, farmer definitely demands, as you spray, the performance should be seen. So if this is the kind of a expectation from farmer, even the biological solution companies should also look at innovating products in such a way that it can speed up the performance. So we started working on the elutes of microbes. Now, we are talking about the first and foremost, water hyacinth, how it is invasive. So it has a more than 125,000 plants will accommodate into 1 acre. And it is about 125 tons of mat in 1 acre of pond. They have hundreds of flowers and tens of inflorescences. Then the seeds are viable for 20 years. So the seed will be under the water or on the heaps, whatever has been drawn out and put on the side of the river. When the river swells again, the seed is again inoculated. So it also has a vegetative propagation. So generally, to clean the lake, they go on chopping and put back the cut matter of the water hyacinth weed back into the water. So it has a capacity to generate one more plant for each piece. So this is the kind of an issue which is happening. And also, physiologically, this plant has got a daughter plant concept by stolons. It will develop a stolon, make a daughter plant, and break the stolon, and it becomes an independent plant. So this is how it has become a perfect invasive with 20 years of viability of seed. So if you don't attend, what happens? Atrophication happens, and slowly the organic matter keeps on building up there. A big lake can become a small creek. So this is the kind of a thing where how we are losing water. This is the degree of infestation of Eichhornia in different states and union territories of India, except for the cold part of northern India, especially to the Kashmir and Himachal. Rest of the India is completely there. So we have also seen, we keep on talking about carbon sequestration and other things, but we are not looking at what is the water footprint we are losing. In this, we have seen evapotranspiration loss is about almost 3.5 liter per plant per day, and it is about worked out to about 5 lakh liters in an acre per day. So generally, we take pride in saying that, okay, we have exported a cup of coffee to so-and-so country and we have realized $2. But they are not counting 140 gallons of water, what is required for making those few beans for making a cup of coffee. If they start calculating 140 liters of water from India, it is the Indian wealth. We are not realizing. So this is the footprint what I am looking. Otherwise, if we save this 5 lakh liters of water per every acre in a lake, just imagine each lake is around 40-50 acres minimum. And how much of water which could be useful for other purposes, either irrigation or for drinking. Now we have also done a study. What we are seeing is water hyacinth is a urban weed. Most of the lakes and other things, they are asking people to remove it. Yeah. So they are asking to remove it. So this is taking a lot of money. They are paying on a square meter basis at a huge price. So if we can reduce the weight of this, then we can save a lot of money on controlling this. This is where we have seen within 7 to 10 days, 85% of the weight is reduced. Then we can harvest it out easily. So I'll go a little faster. So this is the application what we are showing on the day 1. So within 2 hours, you can see the results. So already you can see the leaves curling inwards. And 3rd day, we give a second repeat spray so that wherever we left over can cover. then within 5 days to 7 days, you can see the complete control coming in. Here, what we expect is we need to remove this whatever dried part. If you leave it back, then it will be going into the water and the water turbidity increases. So it is not really viable to keep it inside. So whatever is harvested, we can send it for making as a manure. So this is useful as a good manure. Within 21 days, we can make manure. This again, Parthenium. This is a florific cedar, like more than 50,000 seeds in each plant. So this has a lot of effects on the human health, as well as it impacts livestock. So within 48 hours, we can see the results in Parthenium, and 7 days it can totally dry up on, as you see right side. Then Lantana also we have developed. Similarly, this will also be within 7 days, 48 hours, we can start seeing the results. And Lantana is a major problem with forest fires generally. They also have the Lantana poisoning in cattle. They stop to feed. So for these, we have done the toxicology data on GLP, OECD protocols, and we have also done the ecotox data as well as the bioefficacy data. In 2 seasons, 3 locations data is available. So what we have done is we have also completed the details of characterization of biomolecules. We know what are the biomolecules designed. We are talking about one biomolecule, but we have 3 biomolecules in all the 3 products separately. We have done the NMR studies and we know the molecule, what we have designed. So we have done the bioinformatics studies also, where it is binding and other things. No. This is where, we are knowing where it is binding exactly. So this is binding and photosynthetic pathways 10, 11 and 14. And we have also studied the binding synergies compared with the standards available 20 VD-sites in the market. We have compared the things, and it is doing much better than all other VD-sites with a proof. So we have about 24 patents for this in 15 countries for 3 of our technologies developed. So this is Australian patent, this is the Japanese patent and US patent. We have totally protected this with Biodiversity Board registration. We have also won the strain. We have completed the genome studies, bioinformatics studies. Everything is in line. So we also developed some of the projects which are with rice weeds and some insecticidal molecules we are working, and also some soil fungi control and other products we are working. Thanks a lot.
Thank you, Lakshmi sir, for giving us an insight in bioherbicides. I'm sure soon the day will come when we'll have at least one bioherbicide registered in our country. Disregard.